Hello YouTube viewers, welcome to my show Rocket Monday, episode number 3. So today we're gonna take a look into rocket engines. So let's get started. So what is a rocket engine? In simplest term, it is a reaction engine. It throws mass out as an action, and as a reaction it gets pushed back. Third law of motion from Isaac Newton. Now, the another important part about rocket is that it has internal propellant. So everything it needs, it has internally. That's why it can work in a vacuum. That's why it can work underwater. That's why it can work in atmosphere. It is 100% independent. It does not need atmosphere. It does not need anything. So let's look into it. Now you might ask, how does it work? Well, it has 4 parts. 4 parts is, first part is fuel, or sometimes in rocket industry we call them propellant. Then we have to pressurize it. Without pressurizing it, it will just burn, but it will not give you thrust. So you have to pressurize it. After pressurizing it, you send it into combustion chamber, and in that combustion chamber you ignite it, and it goes through a nozzle, and based on that you get your lift. So these are the 4 parts. It takes fuel, it pressurizes it, burns it in the combustion chamber, and exits it out of the nozzle. Nozzle is the thing that actually provides the lift. So you might want to figure out what is rocket fuel. In simplest term, generally rocket works on gases. Now you might say, okay, then let's fuel it up with gas. Problem is, gas is not very dense. So ideally we want to use solid, but again the reaction is not very stable or controllable. So we try to use liquid as many time as we can. Like liquid fuel rocket has the best mileage possible. So it uses combustion or a reaction to a catalyst to create hot gases. That is the reaction mass. That's why I said rocket engines are a reactionary engine. That is the action it takes. By expelling hot gases, it gets pushed back, or in case it's expelling gas towards down direction and it's getting pushed up. Now, you have to understand, it all has to be self-contained. Rocket cannot breathe. It cannot, like how your car has air intake, it does not have that luxury. It has to be self-contained. So with fuel, generally we also add an oxidizer. Now most of the time we try to use 2-part mixtures. Basically we have a fuel and we have oxidizer. So fuel can be hydrogen, kerosene, rp1, and we oxidize them with liquid oxygen, because that's the best thing we can do. And we try to keep them as cold as possible, and SpaceX has made some unique strions around their cooling rp1. Also they super cool liquid oxygen. Now they can't cool it too low because it will become a solid, and then you can't pump it through turbo pumps. So these is the aspect of the fuel. Fuel has to be self-contained, and generally we have 2-part fuel system. So now we have looked at the fuel, we now come at to how do we pressurize it. We use a turbo pump. Now a turbo pump, in simplest sense, think of it as a turbocharger, and only difference is much more complicated. It works at much more extreme temperature. The cold side goes up to as cold as liquid hydrogen. The hot side goes as high as the melting temperature of the metal. That's why these things are so expensive. They are working at the extreme temperature range, and they are also responsible for throttling the rocket engine. This is where the computer tells the turbocharger to, like, whether I want to more power, this will spin up faster. If they want less power, this will spin up less. To drive these things, we can do few things. You can have battery power, like how Electron rocket does. You can have a separate, which is most commonly used, a gas generator, where you burn the fuel with oxidizer, but generally you don't burn it to 100%, because if you do that, the temperature will go too high. So we generally have too much oxygen, little bit of fuel, and it creates hot gases. You don't want it to be like 3000 degrees Celsius, because it's gonna melt it. Like, we don't make it out of magic things, it's gonna melt. So we have a gas generator that controls this, and this is what pressurizes the fuel. So now you have a fuel, now you have pressurized it. Now what? Now we put it into the combustion chamber. Suffice to say, it is the most hot and the most stressed out part in the system. Now This part actually goes to full combustion. Like this is literally at the edge of melting point. It requires cooling, a lot of cooling. Like there are certain aspects that we can be used, like inside of these chambers can be coated with some sort of abrasion, like graphene. So you get abrasion as it burns off, it cools your system. But generally they are not very popular. So we generally run liquid hydrogen or kerosene, or sometimes even liquid oxygen, although that is not popular, through around the chamber walls to keep it cool, because it's almost at the melting temperature. So this is the most hottest part in a rocket, and this requires the most advanced metallurgy possible. So now we have fuel, now we pressurize it, now we burnt it. Next step. So now we have looked at the fuel, how we pressurize it, how we burn it, and then we have to come at the final stage of a rocket nozzle. So all you have to understand is that while you're burning liquid hydrogen or kerosene in the presence of oxygen, all you are getting is hot pressurized gases. To turn that furnace-like scenario into a thrust, into something that you can put on base of a rocket and make the rocket go up, we employ nozzles. What does nozzle do? In simplest term, it turns the thermal energy into kinetic energy. Basically, it takes the temperature and makes it go whoosh. Now, how does it do that? Nozzle is very simple and it's used everywhere. So all you have is the chamber. You have a lot of pressure in that, like it's want to go out. Now you force it through a throat, or this part, or this part. You force it through a throat and it gets higher speed. Now you let it expand. This is the nozzle part. Once it's expand, it gains the speed. That's the exhaust gas that you have in the chamber. It's very slow, like it's barely supersonic. Now while you are giving it a room to expand in nozzle, it goes at hypersonic speed. It's getting really fast. So that's how it does that kinetic energy conversion. So now you have turned the heat into energy, useful energy. Now it also comes with one caveat: it requires altitude compensation. So these things you see, these are what rocket nozzle could do. These two are acceptable, the last ones. This is not. Your rocket is not going to be stable if you do this. Your rocket is really inefficient if you do this. This is perfectly balanced. And this what happens when you have nozzle that is over expanding. Now because of atmospheric pressure drops as your rocket is going up, you have to understand you can't design one nozzle that can take care of it all. So how we compensate is that if we have multi-stage rockets, we simply say, okay, on the first stage, which is working under atmosphere, we're gonna have a nozzle that is suited for that. And if we have an engine that is firing in vacuum, or like upper stage of a rocket, it will have an engine bell or nozzle that works in vacuum. So this is how we convert the thermal energy into actual physical kinetic energy. That was my presentation on how rocket engines works. Thanks for watching. I hope you guys have learned something, and if you liked it, please like. If you dislike it, please dislike. Leave a comment and subscribe, and if you're free, please press the bell icon. Thanks for watching.